Hello everyone, I'm going to teach you in this video how to make such great time-lapse videos using your Bambu Lab A1 Mini or any other Bambu printer. When you're doing time-lapse, the head with the nozzle rests on the left side, and when it does that, this little device I made takes pictures in my phone or a Bluetooth camera. Here is what you will need: an LEGO or Arduino microcontroller, breadboard, wires, photoresistor as you see here, a transistor NPN preferably, of course, resistors and an LED for test purposes. And you're also going to need a Bluetooth shutter, this board for prototyping, and an Arduino Nano. If you have a soldering, it will be great. Also, you need that to solder with. And of course, small pliers, wire cutters, they're all welcome. So the process will be simpler than what you might be thinking right now. The good news is, besides the controller and the Arduino Nano, everything else is included in this LEGO kit. You can buy this on Amazon, and honestly, if you click on my link, that helps a lot. Even if you're buying something else, this channel is not monetized. But everything you see here can be used to build things like this. And people ask me why I didn't use a ultrasonic sensor, and the reason is they are too bulky. The lighter the system is, the better. Notice the LEGO microcontroller here is quite big, but it's easy to prototype with it. Instead, for this box you see here, I used the Nano device, and once I was done prototyping, I transferred everything to this prototyping board here. But honestly, you can build it the way you want, so long as the sensor is right behind that nozzle or the head in the printer. To make things simpler, let me show you what the system looks like. The link to the system is in my description. Here are the parts that are used in this little circuit, and honestly the LED here is just for testing purposes. In the end, the LED will be a shutter, but because they don't have that in this circuit maker here, I just used the LED to prove the point, and I'll show you guys how to build the entire circuit using the Bluetooth shutter as well. Here is the code. I have a lot of notes on the code and comments, so you guys will understand it right off the bat when you get your hands on this. And the code will be also on the same link as this system. Now let's get to work. I'll build everything on the breadboard first. As you see here, the first piece or the first component we're going to use is the photoresistor. As you see here, I'm attaching to the board. Notice this is something done very quickly, so I'm not making it pretty, I'm just making it functional in a way that you guys will be able to understand how this works so you can replicate it at home. The photoresistor doesn't care about what's ground, what's positive, and so on, so it doesn't really matter where you're connected to, so long as you follow the steps I'm following over here. You're going to need a resistor. It could be a 10K or even less. If you don't know how to read a transistor, you can always use a multimeter as I'm using over here and check the resistance of this. But if you know how to read them, just check the colors and you know what it is. Place the resistor in the same column as one of the legs of your photoresistor, and when you do that, it means they are connected to each other. And I'm connecting it here, and the other side of the resistor will be connected to ground. I could have done it straight from here, but in this case I actually did a wire, which makes me feel a little dumb right now, but that's okay. Let's proceed. Once that's wired, we're going to go to the next step, and the next step will be simple. All we need to do is to actually connect the other leg of the photoresistor to power, or to the positive end of this board. This is a crucial step. Notice the A0 pin or analog 0 pin from the LEGO board. That's where we're going to receive the input from our photoresistor. So the negative or the grounded portion of the photoresistor is going to connect straight into that A0 pin, as you see here. The photoresistor will actually tell us how much light is detecting, or the level of light, and around that number we can build a logic that will work for us. For instance, if there's less light, take a picture. If there's more light, do nothing. And that's exactly the software or the programming portion of this project. I hope everything is making sense so far. If you need to stop the video here, please do. You can check how the photoresistor works online, but all we've done so far is to get an output, either high or low, to make our system work. And the output that I have here is on pin 6. You're going to understand how things work very quickly. So the digital pin 6 basically sends a signal, either high or low, into our system, and that will define whether to take a picture or not. So the next step is the LED, which is basically our shutter. If you don't know LEDs, how they work, the longer leg, it is the positive sign, or the anode, and the small one is the cathode. Now let's say you cut both legs the same length. You can look at the LED and one side is flat. The flat side is the negative or the ground side. We're going to use another 10K resistor here, but honestly it could be a 5K, a 1K, it wouldn't matter that much. But it just prevents that LED from shining too bright. Notice that I didn't put them in the same column as they were supposed to, but I fixed that later on when I realized I made a mistake. Now we're connecting the other end of the LED to a resistor here that goes actually to the positive side of the LED. I know it's hard to believe, but we're almost done with this portion of the project. The next step over here is using the transistor. This is an NPN transistor, and I'll put the number over here on the screen and also the data sheet so you understand the pins. But basically, one pin will connect to ground, one will connect to our system to receive the high and the low signal, and the other one will connect to the LED or the shutter. And here is that transistor, the information you might need. It's a S8050 NPN transistor, but honestly, any NPN transistor would work as well. Now grab that transistor, spread its legs, and make sure each leg penetrates a different hole in a different column. Sorry about that, that was unnecessary. If you're facing the transistor, the left pin is the emitter that connects to the LED, the middle one is base that receives the signal from your controller, and the right one connects to ground. Swapping the emitter and the collector didn't seem to make any difference in this circuit, and that's exactly what I did. I swapped them, but then I fixed them. So this one I connected to ground, the middle one I am connecting to digital pin 6, and when digital pin 6 sends a high signal, it will actually turn on the LED. And when it sends a low signal, it will do nothing. And that's how a shutter is going to work. If that sensor, the photoresistor, is covered, it will send a high signal telling the system to take a picture. And if it's not covered, meaning there's plenty of light there, it will do nothing. You can see here that I connected that green wire or the right pin from the transistor into the LED or the ground portion of the LED, and now the system is almost ready. I'm finally connecting the base now, which goes into that central pin. So whenever this system now sends a high signal to the transistor, the LED will turn on. Therefore, take a picture. I'm going to show you guys how the shutter is going to work in just a second. All of this is just to demonstrate how it works. You can use a battery to power all of this up, but I decided to use the USB because some print jobs are very long and I didn't want the battery dying halfway through. What I did here is very simple. Because the Arduino Nano already comes with that micro USB port to connect to your computer, you can also connect that to any phone charger and it will power your entire system. Look at my controller over here. There is a 5-volt pin, a 3.3, and a couple ground. And that's how we're going to power that breadboard. We're going to connect the 5-volt pin into the red or the positive portion of the board, and the ground are going to connect to blue or the negative portion of the board. Don't mind the colors, I was running out of wires and I wanted to finish this quickly. Now connect your board to your computer and upload the code that I provided in the links. You're going to need to install the Arduino IDE on your computer to be able to do this and upload the code into the board. Once all of that's completed, we're good to start testing. You'll be able to see the readings of that photoresistor sensor and adjust your threshold. But whenever it's covered, notice it goes below our threshold, 314, and then it turns that LED on. The readings you see on the bottom of the screen are actually crucial because you need to set the correct threshold based on how much light's in that room. So play with that and adjust it in a way that will work for you. Now we're ready to connect to the shutter. The battery will be unnecessary and all you have to do is to actually pry it open and remove the board from the case as you're seeing here. Hold the pause button because it might be necessary. Here's how you connect to this shutter. First of all, the pin you see over here that I'm pointing to, that's what you connect to ground in case you need to use this button for testing purposes. Now notice that I'm scraping the resin off of it, and that's to make it easier to solder any type of wire over here. If you don't want to do that, you can also use the little pin you see over here. On the other side, you would connect to the transistor, but don't worry, I'm going to show all of that in a second. This one here, the larger one, is where the battery was connected to. All you need to do is to connect this to the 3.3 volt from your Arduino Nano or the Lego you're using. Let me show you the finished product so you see how everything works together. So everything we built on the Elegoo board is now transferred to this Nano here, Arduino Nano. And I'm going to explain the wire combination over here. The colors again don't matter. So here's what's important for you. The black wire, as you see here, that's connected to ground, as explained in case you want to push that button. The red one is connected to the transistor, that leg or that pin that would connect straight into the LED. And now the white wire is where the battery was, and that connects to the 3.3 volt from your Arduino Nano. And this is the very same device I used to create the time-lapse video you saw at the beginning of this tutorial. The photoresistor is actually on the back of this board, and I'm going to show you the final product so you see where it's located. But basically I fold this together and I put into a little case that I made using my 3D printer, and if you want that design I can also send it to you. This is what it looks like when finished. Notice that you see two holes in my case. I added a potentiometer on the left side over here to change the threshold without having to connect to the computer, but I didn't want to make this more complicated. If you want to know how I added the potentiometer there, just let me know in the comments and I can make a video, hopefully quicker than this one so it's easier for everyone. So this can rest in a phone holder or even on your printer if you want. Now that we're almost finished, let me show you a couple more things and show my face to you as well, not that you want to see it. So guys, thank you for watching this video. I know it's not the best video ever made, but I hope it really helps you create better time-lapse videos for your 3D printer. This is the final device or the final product, as you see. I'm gonna open the back because there's one thing I never showed you guys. Let me remove it from here. So here's the shutter, as I was showing you how to connect to this whole system, right? And we see over here the wires that are connected, the black, the red, and the white. But what you didn't see in the video is this portion. I put the sensor or the photoresistor right on the back, as you see here. Don't worry about the potentiometer. It doesn't do much. I don't even use it. But here it is right on the back of that board. So when I put in the case, it goes right into that hole and it works perfectly that way. But that's what I wanted to show you. If you want to build it something similar, this is how you do it, okay? So remember, this is the Arduino Nano. Everything we built here transfers to this little guy over here. Even the pin numbers, everything. You just have to connect and wire them the right way. But I'm sure you'll be able to figure that out on your own. I'm also here to answer questions. But everything that we built here is in this tiny little controller, which is awesome. Now, look the way it looks on the back, and you can put it, you can make a case for it if you want, or you can just put the sensor right there behind the printer and it would work as well. I hope this works for you. It took me a lot of time to make this video, but the project itself is very quick and very simple. You can buy all these components, all these parts from the link in the description. So I hope you make use of that. Thank you very much for watching, and I hope I'll be posting more videos for you guys to watch.